finally, let's go back to the discussion of time value of money. As we asked in the beginning of this lecture, would you rather have $100 today or $100 in 5 years from now? Even if inflation did not happen, most people would prefer $100 today. The reason for that is that the present value of money is different from the future value of money. We give a specific definition to the present and future value of money. The present value is the amount that we need today in order to get a certain amount in the future, given today's interest rate. Future value, we reverse this definition. We say it's the amount we will receive in the future by saving a certain amount today with a given interest rate. So here's an important thing. Interest rate is going to be important. Why is that? Well, if you have $100 today, most likely you're not just going to put it in your wallet and forget about it. If you're not buying a new pair of shoes, you're going to put it in a bank and you're going to make some interest on that money. So in the future, you're not just going to have that $100, but you're also going to have that $100 and earn some interest rate. So let's see how we calculate present and future values. We have specific formulas. Future value is the amount of present value multiplied by 1 plus r taken to the power of n. Present value is the future value divided by 1 plus r taken to the power of n. So if FV and PV stands for future value and present value, R stands for the interest rate in decimal form, and N stands for the number of time periods, either years or days or months, depending on per which period you're earning your interest rate. Let's look at the example. Instead of buying a new car for $35,000, you decide to buy a used car for $10,000 and put the rest of the money into a bank that pays 5% interest rate. We want to know how much money will you have in 25 years. We need to use the formula for the future value. So we're looking for the future value of $25,000 that you saved times 1 plus 0.05, which is your interest rate, taken to the power of 25. At the end, you will get $84,000. Not bad, huh? The savings from not purchasing a new car. What if the interest rate was 6%? Then we would have future value equal to 25,000 times 1 plus 0.06 taken to the power of 25. I actually want you to calculate this number yourself. If you do everything correctly, you will see that this future value is going to be greater than the future value when interest rate was 5%. What does it mean? As interest rate increases, the future value of money increases as well. So future value is higher when interest rate is higher and the time period is longer. Here we had the same time period, but if you increase number of years, you'll see that future value will increase as well. Let's look at the present value example. If you want to retire in 30 years with $1 million, how much money do you need to put in the bank that pays 4% interest rate today? So we're calculating how much money we need to have today in order to have $1 million in the future. We're going to use the present value, right? Present value is how much money do you need to have today in order to receive a specific amount in the future. So we take 1 million divided by 1 plus interest rate taken to the power of number of years. So you will get $308,000. So if you have this amount of money today, and there is a bank that pays you 4% interest, if you never touch this money, if you let the interest rate accumulate, in 30 years from now, you will have $1 million. What if interest rate was 6%? Then we do the same calculation, but instead of interest rate of 4%, we'll have interest rate of 6%. And you see that you will need only $174,000 in order to receive $1,000,000. Of course, the difficulty is to find a bank that pays you 6% interest rate. So what we can say is that present value is lower when interest rate is higher and the timeline is longer. So we reverse that result. This concludes our lecture that discussed financial markets.